just going to make sure we are live. Okay. Yeah, on the decontrol one, there we are. Looks good. Do we hear it? We are live. Perfect. Yeah, DCTRL van. Yeah, that is live. There it is. There we go. We're doing it. Look at that's Inception, because it's like you're looking at yourself, right? All right. Thanks everybody for coming out. Sorry for the small technical difficulties, but we are live. We just want to make sure everybody can hear this at home and later on. So thanks again. We've got a great showcase of everybody showing up today is amazing. I know it's really beautiful outside, so thank you all for making the time to show up here today. Okay, so Monday nights we have poetry night. So if anybody's looking to do some sort of stand-up speaking and poetry stuff, there's a Monday night that's happening. Every other Tuesday we have jam night. When's is it coming? This coming Tuesday? So the following Tuesday. So you got to wait a little bit. But it's jam night on Tuesdays. And have we got anything else that is kind of cooking here on the calendar? DJ nights. Sometimes we've got DJ nights, sometimes Friday. I think we've got some stuff going on there. Yeah, those are kind of the main things. But yeah, for anybody that's who's not been here, we got a whole bunch of new faces before. Oh, we got a few hands. Okay, awesome. So yeah, welcome. Thank you for coming down here. We'll if you have any questions afterwards, I know this place is super straightforward. It's not confusing or complicated at all, but we're happy to help you. So we've got, if you scan those QR codes up there, one of them is for the ETHVan Discord. The other one's for Decontrol, which is like the space here. So as you can follow the Twitters and the Discord and get all the other answers to all these magical questions that you might have here later on. Okay, with no further ado, we are going to get into it. So we've got Eric from Coinbase is about to tell us all about x402 and why it is the internet native payments for humans and AI agents. Thank you, Eric. Take it away.
This is a little awkward. I thought I was coming to poetry night. So I think I got about 20, 25 minutes of slides, and happy to take any questions, ideally at the end. It's got a little narrative to it. So hey, I'm Eric. I think the first time I was in Decentral was like 2015, 2016, back when there were still the carcasses of Bitcoin miners up on the wall. I'm here to talk about x402. So x402 is a HTTP native payments protocol that we've been working on at Coinbase. It's an open protocol, open source. All the code and other snippets that I'll show tonight work now today. They're on GitHub, Apache license. Check them out, play around with it, let me know what you think.
Do you work for Coinbase?
I do work for Coinbase, yeah. Well, it says right there. I'm the head of engineering for Coinbase Developer Platform. So what CDP does is we're the, think of it as like the AWS within Amazon that is Coinbase. So we try to help make it easier to build in crypto. So who am I other than that? There's a lot of things here that I've done, but really the takeaway here is I've done a lot of stuff at kind of the intersection of AI, Web3, crypto, and just like Web 2. And so I know a little lore. I got some lessons under my belt that I'm happy to share. So the context of this talk is the internet was designed for humans. And I have this belief that broadly agentic usage of the internet is going to be good. And so my thesis here statement is by creating new standards, we can make the internet better for both humans and agents. And so let's start with the first part. The internet was designed for humans. Way back in the day, before I was born, before probably most people in this room was born, the World Wide Web project was released out of CERN and Tim Berners-Lee. What actually was it? So HTTP 1.0, which was released, was effectively HTML, HTTP, and the web browser, which at the time they called a www client. Really what it was is a set of standards to communicate with each other to display information for humans. And this constituted Web 1.0. This is really the read era of the internet. We got to Web 2 eventually with the write era of the internet with JSON, AJAX, JavaScript, TAD interactivity, and in the first phase of the internet, we ended up with a lot of let's say, research papers shared, and then Web 2 ended up with Uber, Lyft, every big company anyone in this room has ever heard of. But really what these things are is they're standards. And the web as a concept evolves through standards. So in Web 1, we had HTML for format, HTTP for transport, browser for how to deliver and render those standards. And then Web 2, we got JavaScript for interaction, Ajax for access, JSON for a lighter, more machine-friendly format for communication. But the current set of web standards were designed for humans to operate computers. And we're now entering a world where both humans and computers will operate computers. And so, this nice lady's super happy. She's got 2 computers with her. The robot, the machine, is quite sad because he lives in an unoptimized world. So what is an HTTP request? Brief primer for anyone who hasn't built an HTTP server from scratch. So this is the literal bytes that get sent across the wire when you make a HTTP request. You have a header, you got a path, you got some content, you have query parameters on the top left, and then on the bottom right, you have what a server will respond to you with. And that's how every interaction pretty much all of us make from our phones or web browsers or anywhere else works. Those little headers and those little pieces of data accompany probably every action you take thousands of times a day. And right now with the internet, we're really good at answering and asking the question, how do I give you information and what should that information look like? But we have not answered the question of how do I give you value? There's no common standard of the internet of here's how you give me money. It's an unanswered question. And we'll get into that a bunch in a minute. But we're transitioning from a phase where users of the internet are humans to humans and bots. And so far UX has been human-centric. So we've all heard of LLMs, hopefully in this room, large language models, the underpinning of OpenAI, ChatGPT, Claude, Anthropic, et cetera, et cetera. Why is it hard for LLMs to understand the web? Well, the internet was designed for humans. This is what a human sees, this is what an agent sees. We see the nice rendered DoorDash menu with all the images and the text, and some designers spent a ton of time making this look pretty for us as humans to experience. On the right is the HTML that actually underlies that web page. It's the literal HTML. I copied it from the source code from the browser. And that makes agent sad. Why does it make it sad? Well, you might have heard of processing tokens when it comes to an LLM. That HTML page, I ran it through a token calculator, has 600,024 tokens. Currently, it costs about $3 per million tokens. That means even just reading that web page costs $1.87. You also suffer from this concept of needle in a haystack problem. And so LLMs are bad at retrieving information when there's a lot of extraneous information that doesn't matter to them. Basically, if your boss told you like 600,000 things and about 1,000 of them were relevant to your day-to-day job, that's a 0.16% signal-to-noise ratio. If only 0.16% of things you were told were actually relevant, you would probably be pretty bad at your job too. It's just, that's how these things work. I originally made these slides for an AI conference, and I figured for the AI conference I had to include some math, so this is my math formula. Expensive and low quality equals bad. I don't think that's controversial, but the frustrating thing with the internet is that the more optimized AI data is there. If anyone's done any web dev, you know that somewhere in the stack is a database that has all this data in a perfectly fine machine-readable format to power this UI. And then at some point, it probably gets rendered as JSON, and then it gets converted to JSON and then rendered into an HTML page that we as the humans see. And that thing that gets passed into that render step is actually a perfect piece of data to give an AI agent. Look how happy he is. He's got a nice smile. But there's no, and this is what rendering looks like. It's understood. The data is there. The files are in the computer. There's no issue with the data. The issue is with the incentive. There's actually no incentive for DoorDash to give you all the menus available in your location programmatically because they want to capture value from you when you buy things on DoorDash. There's no incentive to just give away the data because the data has value, but the monetization isn't direct. It's via the action of you look at their data and then you choose a thing to order and then they take a fee when you order. And payments are the worst part of the internet. I said at the top, there's no standard for answering how do you pay for something. Typically, this is how humans pay for things on the internet. It's this huge credit card form we've all seen. And that has worked really well. Payments are, I would argue, the most important economic unlock, if not, certainly of the internet, if not of like global GDP in the last 25 years. They're also significantly the most human in the loop. And if you go through this field has 14 fields. Granted, there's like repeat UX where you add a credit card on file and blah, blah, blah. But broadly, like initial payments on the internet suck. And it's worse for agents. And why is it worse for agents? Because agents turn tasks from deterministic to probabilistic. So if I write a program and it just prints to console, the same thing reasonably with the same drivers and blah, blah, blah is going to happen every single time. But with an LLM, there's a probability that the thing that you expect is going to happen is actually going to happen because these are statistical models. It might happen 95% of the time, but it's not going to happen 100% of the time. And so that's part of the reason why it's bad for agents. It's like filling out that form, it's 14 tasks to complete for an AI agent. Factor out browser usage, blah, blah, blah. I'll talk about that in a minute. It's just 14 things where even if it's 90% accurate, it's gonna, that's, P90 times P90 times P90, like your actual success rate ends up being like roughly 0.35. Don't double check my math, I did that in my head. Agents don't have credit cards as well. Agents would need to be really good if you're gonna trust them with a credit card. Like really, really good. Because credit cards are legacy things where I think most people in this room would be shocked how many times there's actually a fax being sent somewhere downstream of your credit card being charged. Because these payments weren't made to be digital. They were made to be done between banks. I am just old enough where I remember someone taking like a scan of a credit card when I'd buy like Scholastic books as a kid. And that's because they would take that to the bank and the bank would debit the account and then they'd like wire to another bank and there's a fax and it's a whole deal. And it's preventing what I call the rise of dynamic agents. So what is a static agent? That's the alternative to, let's compare and contrast. So a static agent is an agent with a static set of functionality, manually integrated tools chosen by the developer, capable of handling specific problems. That's roughly where we are here. If anyone's built an AI agent, you gotta go and manually integrate each tool that the agent wants to use. MCP and things have made it a lot easier, but you still gotta do a bunch of work. Dynamic agents are an agent with a dynamic set of functionality, task-determined tools chosen by the agent, not the developer, and that is capable of handling arbitrary problems rather than vertical problems or specific problems. And so let's visualize this a little bit. Let's say I want to have an agent. I want to give it a prompt of make a joke that involves tomorrow's weather and today's S&P 500 price. An LLM can't answer that because it doesn't know what the weather tomorrow is. So it needs to use a tool to go and get the weather, and it also doesn't know today's S&P 500 price, or a lot of people would be a lot richer than they are. And so you need tools. With a static agent, the developer goes and integrates those tools. He finds an API for weather. He finds one for stock, adds it to his agent. Agent uses the tools to fetch the data, makes the joke. With a dynamic agent, an agent could realize, oh, I need to get stock data. I need to get weather data. Find those tools, autonomously purchase them, and use those tools, make the joke. You might say, does MCP solve this? Again, this is a very ML-heavy conference. I did this at first, so MCP is a protocol for specifying interactions between tools and agents, if anyone's not familiar. Partially, MCP standardizes access, but not discovery, authorization, or payment. It's not a kill-all. And the other thing with MCP is that every MCP tool, almost all of them, require an API key. And agents can't provision API keys. See slide about payment forms and blah, blah, blah. So we have Web 1, we have Web 2. Broad thesis, it's time to start adding new standards to the web with AI agents in mind. And I think payments is the biggest problem with the internet. I think it's time to add a standard for payments. So an open payment standard for the internet. All that was preamble to get to where we are right now, which is talking about x402, which is the title of the slide. So way back in the day, I believe it was in the late 70s, we added the 402 status code to the HTTP spec. For folks who don't know what an HTTP status code is, it's a way for a server to tell a browser what went wrong. So if you get a 200 status code back, you're Gucci. Everything went great. If you get a 500, they've had a problem. If you get a 400, you had a problem. 402 says, and this is the entire text of the spec when it was published, 402, payment required status code is reserved for future use. In fact, Mark Andreessen, big, bald guy, pretty influential, pretty smart, he's done a lot of stuff. has this quote. So I think the original sin that was that we couldn't actually build economics, which is to say money at the core of the internet. And he goes on in this long quote to describe like you may want a direct relationship with the article that you're purchasing, but the economics of that don't work because credit card fees, et cetera, et cetera. They actually tried to make it work. It was a fun fact. Back in the 90s, Mark Andreessen tried to work with the banks and the credit card rails to natively build payment rails into the Netscape browser. But he got caught up in a million pieces of legal tape and performance issues and cost issues, yada, yada. By the way, fun piece of trivia. Does anyone know how we got the image tag? Any web historians here? IMG tag. We got the image tag because Mark Andreessen just put it in the Netscape browser and everyone else was like, that is a good idea. The image tag did not exist until Mark Andreessen just shoved it into the Netscape browser, and they were the biggest browser at the time, and people were like, okay, I guess we should do that too. Influential guy, that Mark Andreessen. So this is not the first attempt to do payment standards on the internet. So Coinbase tried this back in 2015. 21Co, which was a Bitcoin personal computer company, tried this in 2016. The W3C consortium took a draft at it in 2016 as well. LSAT, which then evolved into L402, was a Bitcoin-oriented solution for this that started in 2020. Some of these worked, some of these didn't. 21.co is one. There's code here. It actually worked at a point in time. Well, worked in that you had to go through a full Bitcoin block, and so your web request took 10 minutes, but it technically worked. There's been a lot of attempts at this. The logical question is why one more standard? We'll get a lot into that. I think I went through before when we were designing X402 and evaluated every standard I could come across for payments on the internet. I don't think any of them are good enough for where we need to go. So X402 is my attempt to make a standard that kind of solves some of the UX problems. By the way, I authored X402, I authored the spec, I wrote the code. There's a team that helped me with all the SDKs and everything else. Big shout out to all of them. But if anyone has any real in the weeds technical questions, I know this audience can be a little all over the place in terms of technical level. I didn't want to go too deep on it in here, but come find me after the talk. So here's the demo of X402. We click a button, we connect the wallet, we click Pay Now, we click Sign. For anyone who's ever done a transaction in crypto, this seems pretty unexciting. The exciting part comes when you see what it's like to integrate X402 into a program. So even if you have a wallet connection flow on your website, that wallet connection flow isn't necessarily going to work. It's stateful. It only can operate in the browser. If I have like a headless wallet or like a bot, I actually can't pay you money in 99% of wallet connection flows. And so to make a payment with X402, getting this page is one line of code. Paying this page programmatically is also one line of code. So all we do here is we take Axios. We also support Fetch. We have like Go, Java, a bunch of languages. We wrap it in a wallet with this interceptor, and now you can make HTTP requests that pay in line. And so that line 21, this guy right here, that's literally just how you make a GET request using Axios. And the client will navigate the protocol for you because it's a standard. There's a standard way of navigating the protocol. Anyone who knows what the protocol does and how to traverse it can write a client that just does the thing. So we go from 14 fields in a credit card payment field to 3 clicks or 2 lines of code to pay for stuff on the internet. Pretty good. I was hoping for 2 clicks, but that last click is going to take another couple weeks to get out. So X402 as a whole, there are 0 fees. It costs $0 to transact on X402. If you are accepting $5 of payment on X402, $5 will hit your account. I think people are always a little skeptical of Coinbase in the crypto space and like, oh, how is Coinbase going to do this? There is 0 fee. You can do this completely without Coinbase. It's all standards. We recommend a 1/10 of a cent minimum payment for minimum amounts. This will drop over time. It's largely a function on gas cost. Right now on Base, doing an ERC20 send is roughly 1/100th of a cent. And so, but at some threshold, the economics of gas versus value captured start to go away. It's HTTP native. X402 is a standard. And what that means is that it exists in the requests that a client and server are already doing. I got a diagram that shows this later, but if your browser makes a request to a server, that's it. There's no extra hop. You're just including a header in that request with x402. There's no x402 needs to like call out to like some third party and come back, and your browser needs to call out to some third party and come back. And that means that it's completely privacy preserving as well. You're only ever talking to the server you intend to talk to. There's no third party like that you hit from the browser. This is like there's this concept of a facilitator I'll get to later that helps abstract the things on chain, but they never actually get any exposure to the end user that's paying for stuff. And then critically, and I think like the 21earn and LSAT and others like are very Bitcoiny. I love Bitcoin, but I think you need these standards to be blockchain agnostic, and I think you need them to be flexible enough for the future. So there's a bunch of mechanisms in x402 that allow it to evolve into more complex payments. So what do I mean by that? If money's fully programmable, you can do more clever things with money. So the most obvious transaction, the one that's been happening since we formed currency, is I would like $5, please give me $5. Pretty easy. You have more complex transactions you may want to represent now. For example, I may charge you up to $5, but I'm actually not sure yet because I haven't done the processing yet. An example of this is like if you're generating LLM tokens, you don't know when you start how many tokens the AI agent is going to generate. And so you don't actually know how much you need to charge the person at the point of the request. And so x402 has a mechanism we call schemes that allow you to build in more complex payment flows like that, where you say, hey, at most this, but it probably less, right? So x402, the goal really is better UX for humans and agents. How does it work? Well, in short, blockchains have gotten really good. I mentioned Base has gotten really good. Solana, Sui, many blockchains have gotten very, very good. We're talking, 1 second, 2 second blocks, soon to be 200 millisecond blocks. We're talking 50,000 transactions per second or transaction per block on a lot of these chains, Sui, Solana. And because of that, it's time for a bridge between Web 2 and blockchains. And that's really what x402 aims to be, is this bridge that makes blockchain technology accessible to the rest of the internet. Blockchain and crypto as a whole is really an island in many ways that kind of sits next to the rest of the internet. And a lot of people actually don't realize how good fundamental blockchain technology has gotten, because crypto is often associated with meme coins and all sorts of other stuff going on. The tech is good, and if you exit anything, if you leave the stock with any takeaways, like go champion the tech. I think more people in crypto need to be talking about how good the fundamental technology in the space has gotten. So what actually is x402? So x402 is an agreement that you will return a 402 status code with a standardized JSON body. It's in the GitHub. We can go over it later if people want. As a client, you're going to make a request with a header containing a signature that authorizes payment. That's critical. It's a signature, not a transaction. That's so that the client doesn't need to pay gas. You can delegate gas to other participants, which means you don't need the native currency in your wallet. And it's an abstraction for settling on chain. That's that last bit. Someone who's paying for something with x402 doesn't need gas token in their wallet. And I think that's actually a really important design decision to make. And then it's this mechanism I described that allows you to evolve to more complex forms of payment over time that we call the scheme. x402 is also a set of principles. So x402 is an open standard. x402 will never force reliance on a single party. There's never going to be a world where you only can use Coinbase's facilitator with x402. The facilitator spec is also open source. There's an example one out in the repo. It is also just a standard interface, HTTP interface, between a client and a server. It's HTTP native, meaning it will seamlessly complement the existing HTTP requests made by traditional web services. It should not mandate additional requests outside of the scope of a typical client-server flow. It's chain and token agnostic. We welcome contributions that add support for new chains, signing standards, or schemes, so long as they meet our acceptance criteria laid out in contributing.md. Our acceptance criteria is really, whenever you're dealing with money, there's opportunity to do abuse and make systems that are bad. And so we don't want those systems to be in, so we want to keep an eye on it for now. We want to be trust minimizing. All payment schemes must not allow the facilitator or resource server to move funds other than in accordance with client instructions. If you agree to pay $5, that it should technically not be possible, should physically not be possible for more than $5 to exit your wallet. And it needs to be easy to use. This is, I think, the most important one. X402, in order to succeed, needs to be 10x easier than any existing way to pay on the internet. This means abstracting as many of the details of crypto as possible away from the client and the resource server and into the facilitator. This means every client server should not need to think about gas, RPC, etc. So let's go through a technical flow. If you're non-technical, feel free to zone out, grab a drink. I'll note step 1 and 2 in this are optional, just to preempt. So let's say you're a client, a web browser, an agent. And I'm personally fundamentally of the belief that like things are both better and more interesting if they're open standards versus closed standards. You can just fundamentally do more if you have permission to extend the standards. Hence why we're trying to make x402 an open standard. And if we don't have something like x402, I think we're at risk of payments on the internet being AOL. It's probably just the current, big payment providers taking 3% off of every internet transaction, and the room for innovation is kind of gated by the people who own the walled garden. And so that's x402. Dynamic agents, 2-click payments for humans, a better payments for the future of the internet. It's part of what I consider a set of emerging agentic standards. MCP is great for transport and format. I think x402 has a great chance of being a good standard for payment. And there's probably more of these that we should consider as we continue to bring agents more and more online. So, thesis again, by creating new standards, we can make the internet better for both humans and agents. If you want to check any of this out, x402.org is the website, github.com/coinbase/x402. All the code examples I gave you are open source. All the spec scheme, it's all there. Literally, there is like nothing that isn't open source for this. If you want to see the rest of what I do in my day job, check out cdp.coinbase.com. And then if you want to follow me on X or Farcaster, I'm @programmer. That's all I got.
All right. Is this where? Oh, turn it down a little bit there. Yeah, amazing. Thank you so much. Appreciate all of this. If you've got questions out there, please grab a mic. We'll can get you to ask anything if you need. Yeah, go ahead.
When you're using like a wallet payment, what does the user see in the signed message? Like, do they see that, oh, you can only charge $5? How does it get the point across to the user that I'm only allowing this a certain limit, that kind of thing?
So that really comes down to the wallet that they're using. So for like Rabby or Coinbase wallet, they'll show you like -$5 in the signature because they understand the IP 309 type messages. But it's the wrong layer of the stack, I think, for us to be opinionated. Like, people should, now go and compete on what is the best UX for humans. We got some opinions. We have like some open source stuff that gives you like a pretty decent paywall out of the box. But, part of the beauty of it is like you can just go build your own if you think you have a take on what it should look like and what the UX for a human should be.
Cool, thanks.
In regards to the human side of this, do you like we were talking about doing this on online and internet and everything else, but what about like point of sale systems? Does this make sense to be using the x402 in there to be like, does that simplify anything for like in that sense, where if like I want to spend crypto, could it actually work to be to be using x402 as far as for point of sale devices?
I think it. So I saw a demo of someone who built an embedded, like a robot that could pay for stuff with x402, like an embedded microcontroller that could make requests. And so I think the like paradigm that is probably most useful is that previously you would have had to have a hot wallet somewhere in the system to accept payments with at a POC. And so you absolutely could make payments with x402 at a POC, and you can like just expose the data in a QR code, or just have a QR code that goes to a like a page that is in the loop. Is it the most optimized for that use case? Probably not, but it would definitely work, and it would say be a UX bump for POCs not having to deal with gas.
If the whole thing is built for the agents, then why is there even a front end with a wallet button? Like, why is it not just humans and it? Okay, fair enough.
Yeah, we got to do both. We're co-tenants of the internet now. I think she was first as well.
Sorry, terribly rude. Where do you see the sort of ratio of humans to agents long term? How accessible is it going to be for human payments versus, I mean, you can see it for agents, right? But what's going to come first in terms of adoption?
It's a good question. I think the more interesting question is what does more payment volume? So I think agents will certainly win on number of transactions, but I expect those transactions to be like frequent and small. If I look at the data, like there's a Dune dashboard I made yesterday when I had 30 minutes, and I think the average size of payment right now on x402 is about 80 cents, which you literally cannot do an 80-cent transaction with a credit card right now. It's credit cards take 30 cents and 3% of any transaction, so charging 80 cents is like, it just kills your margins. I think we're also going to see hybrid systems where, for example, in the interim, where you might ask an AI agent, like, I want to go on vacation to a beach in 3 weeks. I have a budget of $1,500. I'm located in Vancouver. Go and like find me a bunch of options. And the problem is like, okay, what is the weather going to be like in 3 weeks? What resorts are available? Like, which places do I want to go? A lot of that data is hidden even from search, or like hard to parse if search. See many slides ago. Man, I have so many slides on this. I think you could see the AI agent pay for the equivalent of the like DoorDash menu across a bunch of things, like gets the weather in the cities that it's researching, pays like 10 cents for access to that data, and then says like, hey, here's the thing, and then you do the last mile of payment with a credit card in the interim. But who knows? I suspect agents will be higher volume over time because they have more of a need for programmatic usage, but
Can you go back to the slide that shows like the walkthrough of how it functions? Sorry.
This is
Almost. Yeah, that
this is
guy.
my own fault for being long.
Got it. Sorry, I think I might fundamentally misunderstand how it works, so I'm sorry if it's a stupid question, but if I understand, so if I'm a user and I already have, you're saying it's gasless, right?
Mm-hmm.
And I'm a user and I have a crypto wallet and I want to use that for transactions throughout the internet which aren't currently enabled. And so I'm, a user, I know how to work with crypto already. So when I go to the website, I'm the client, right? And I'm like, my browser is the client, and it's like trying to do something. The server says, ask for money. And so here, this is where I would be used to just like my wallet popping up, and I press send and I send the transaction. I pay for the gas because it's on the network of my choosing. But here, like on step, there on like the facility, here's where I get a little confused. Like, are you implying that like I've given some control to a facilitator, maybe that's like Coinbase or something, who then doing the transaction in the background, and hence that's why I don't pay the gas? Like, I guess I just don't really understand. Maybe I just misunderstand it fundamentally. Yeah, for sure. So a really important EIP, in my opinion, is EIP 3009. So what EIP 3009 is a way of signing a transaction that can be broadcast by anybody that conveys the transfer of value. And so, yeah, you're delegating the transaction to occur to the facilitator, but they can't take any actions on your wallet other than the thing that you've approved. And so the reason I just unlocked my one password is because I can show you the demo, and it might make it clearer. So if you go to x402.org, you can go to try it out. This should work. Let's see how much of my wallet it shows. So I'm connected. If I click pay now, I get a little pop-up, which y'all can't see, but let me change my screen mirroring setup. There you go. So I'm being asked to sign, not transact, right? To pay 1 cent. And, you can see the full message data. This is what I was saying with wallets, like have different UXs around it. What you're signing is this message, which is EIP 712 sign typed message data that follows the 3009 spec. And what you're basically saying is like, I'm willing to transfer some amount from my address to another address with this much value. Like, you can do it after this time and before this time. And so there's like, you can set a 10-minute expiry window or something for where the transaction must occur. And then you also have a nonce, which you can then use to invalidate the transaction if you get FOMO. If I click sign here, it'll settle a block, and then we'll get access to payment.
That song is very loud. And I think that's key because I suspect that a lot more people are going to have stable coins than are going to have gas coins.
Sorry, I guess like, so if I understand correctly, like the 0.01 cent left my wallet in that circumstance and went to you, but you're saying the facilitator paid for the gas in the background.
Exactly.
So the facilitator, so there always has to be somebody paying the gas, and it's about who's willing to do that. In this case, it would be Coinbase, or like how, you know, how does it work like magic for like a new user on a new website who might not want to?
Yeah.
Is it that the API? Oh, is it that the request itself is gasless, but the facilitator's essentially abstracting away the gas in the transaction?
That's exactly it.
Okay.
The HTTP request contains a signature that can be brought on chain by anybody. And what the facilitator does is it's a standard way to bring things on chain. And so okay, you might ask, why might a facilitator want to do that, right? Well, I think that is like facilitators, if successful, that's like the next Stripe. But you as a person, you don't have to use the facilitator. You as a server can just be like, I'm fine with just paying the gas. Like all my transactions are like for $1 and it's 1/100 of a cent. I'm willing to take on the complexity of paying the gas. You can just pay the gas. You yourself as the person running the server. But I suspect if we want broad adoption, we need to give ways for people who aren't comfortable running a hot wallet and taking on that complexity to not have to deal with that, right? They just receive stable coins or tokens in an account. And like I said, the facilitator is optional, and then you like Coinbase's facilitator is like because you know the gas is trivial, and the gas is, by the way, so low that like I did the napkin math to like of how much ETH to put in the wallet on Base, and it was like $40 will handle 500,000 transactions, right? Like these are the economics of blockchains now, and so I suspect what you see is the gas cost isn't the main cost for facilitator. It's like the engineering and everything else, and so facilitators actually compete on value-added services like accounting and like revenue dashboards and like, oh, can I give you something that your accountant as a business, your accountant isn't going to be pissed off when we have to file this, right? It's like the value added software rather than the use of the protocol that is like the thing to do, that is the thing to compete on.
Got it. Thank you. So then I guess it's like up to the business who's offering
Correct.
x402 payments to decide if they do it themselves, if they use a facilitator, which facilitator is best for my needs. Okay.
Exactly. Yeah. And I think if standard becomes really prominent, like you're probably going to see like dozens of people with different facilitators competing. And because there is no mechanism in x402 to actually capture a percentage-based value, all the fees are going to be SaaS-based rather than percentage-based, which is a massive unlock.
Thank you.
Yeah, I do have a question. So like the format of the transaction that you showed that we signed it now, I think it's not like a legit Ethereum transaction. It's like it cannot be like ERC20 transfer, right? Yeah, but what was the token that you transferred?
USDC.
But that one, is it like ERC20?
Yeah.
So how would you do that? Because like the transaction was not an ERC20 transfer, but we did it.
The thing that people miss is that most ERC20s don't adhere to only the ERC20 standard.
Yep.
The ERC20 standard is actually very, very small. We can go pull it up if you want, but there's actually only like 6 functions. And so
yeah, I know.
Most ERC20s also adhere to like, I forget the standard for permit, but like permit as a standard. There's a whole doc on why we did 3009 instead of permit. It comes down to the number of signatures and being able to delegate bringing on chain. But 3009 is common enough where you get a lot, and it has, in my opinion, the best like trade-off of UX and security compared to anything else for the goals I described in the principles. There's like a whole analysis in the repo if you want to check it out.
So was USDC token previously like 309 compatible, or did you make it compatible for like X409?
As much as I wish I did, I have zero ability to influence the USDC. It already had 3009.
Okay.
You mentioned briefly about the fees going to be SaaS based. I guess what's going to stop the SaaS based thing becoming a percentage thing, because I mean the percentage thing is obviously going to be more profitable for facilitators or whatever to run, right? And we like the it's going to be the if not different, it's going to be just this tiny little bit difference, right?
Competition is the answer.
From other
Correct.
facilitators.
Yeah.
Okay.
Why would you use the one that charges you 3% versus the one that charges you $10 a month?
Yeah, I mean, but I guess the question there is like, why wouldn't they collude then? Just all like say, we're gonna go to all put back to the credit card percentage, right?
Because it's an open standard. Like, if they started colluding, like you or I could see the business opportunity and be like, oh, actually, it probably costs. You could run a facilitator on like a $20 a month droplet, and then just charge, you can charge a trivial amount, right? And you could charge using X402. I'm just saying, because there's no consortium to join, or it's similar to like how margins are basically fixed across the industry on like cloud compute. Like $5 droplets exist. There are other compute units that cost more that are optimized for memory and such, but because you don't care which like computer you run on, if it's Amazon or Google, like there's healthy competition. And margins are like pretty fixed just because of the game theory of economics. There's no, like, other than value-added services, there's no moat you can really have as a facilitator.
I guess also, what do you think would be the biggest threat to this particular thing? Like the traditional banking system, they're not gonna just like sit there and do nothing, right?
I don't know if I agree with that statement, but I can't really talk about that. So I think by far the biggest threat to something like X402 is adoption, right? The thing that big financial players want, if I was Visa, the thing that I would want is for something like this to not exist. And so I would just not give it attention, and you can't really create an incentive for people to not do something. All you can do is ignore it, right? And so I think lack of usage and lack of adoption is, I think, by far the biggest threat to any protocol.
I was gonna ask if you could tell me about like the difference between is the 3009 EIP like similar to how like Seaport works for NFTs? Like, is it like when you're giving permission for the transfer of your 720s or NFTs on an OpenSea or Blur in the marketplace? Like, is that the same thing happening here? And if so, does that mean every facilitator has their own thing? Do I have to give permission every single time to each of this facilitator? Meaning, then I have to one by one reject that open permission that is like very specific. Like you could take 5 cents for these services, but then that remains open. Or how does that work?
This is actually exactly why we didn't use permit, because
that's permit and this is something
permit
else.
requires a specific sender. 3009 doesn't require a specific sender. Gotcha. Right? And so, has anyone ever actually read the USDC contract? Just me, that guy. Cool. You'll notice that you kind of have to pick and choose, right? There's trade-offs to every one of these EIPs and standards, and it's 3009. It has a lot of really nice properties. Again, let's go to the GitHub. There's like a whole analysis in here of like why I think that the for exact payments 3009 is currently the best EIP that exists. Like, just read this appendix if you want my. But you have to. The thing you need to pay for is you need to approve every transaction, but you don't need to do an approval to a new facilitator and then do each transaction. You just sign. It literally, when I did this demo, it could be any facilitator in the world that settles the payment. I need to sign to it, say I'm willing to pay this, so someone couldn't take funds out of your wallet that you haven't approved, right? That's one of the principles. But that's one of the nice things you get with 3009. Yeah.
just wondering. So, what does adoption of this look like? Just
Well, that's a great question. We're doing like roughly 4 or 5. I think we did like 480 transactions last week across, I believe it was about 20 different people accepting payment. Protocol is 3 weeks old now, so still early. Takes a little longer for people to build stuff. But there's some, I think the thing that I'm bullish about is that there's some really interesting things that have popped up so far. So one example I really like is, let me find it. This one. So what this is deep research, which folks here may have used, by Heurist. And what it is pay per research task deep research. So instead of subscribing to $30 a month with OpenAI, you can pay them $1 of USDC. I thought this was the link to the site, but where is it? There it is. So I can do something like, connect my wallet. I forget if I have mainnet funds in this wallet, but we'll make this wallet connection part a lot easier too. We got some stuff coming. Tell me about x402. I just signed if you weren't looking. I don't have sufficient funds on mainnet for this wallet, but the people are like this, I had no idea they were building this. Like they just like tweeted it out, and I was like, oh, this is sick. So we're starting to see more and more of those pop up each week of people organically building stuff without talking to us, which feels like a pretty healthy sign to me on adoption. It is like the struggle with this protocol, right, is that it's a double-sided market. You need a certain amount of supply and you need a certain amount of demand. And so a lot of what I've been doing is just swinging back and forth between the supply and demand side and trying to activate more people both to accept and to build things that are capable of paying with the standard.
Can you go back to the diagram you had?
For sure. This is like, it's literally in the README if you want to not have to look at my slides.
Yeah. So if you look at the step 7, it says do work, and you settle after doing the work. Why is that before the settlement?
So it doesn't have to be. You could accept payment before.
Mm-hmm.
I think that the problem is refunding. So what if your work fails? Like what if your DB isn't connected, right?
Mm-hmm.
And so we recommend like literally having the data you're going to give before you accept payment, because settlement is like a whole rabbit hole that you have to dive into. And we want to add a way to basically give refunds as part of the protocol, but like candidly, it doesn't exist today. And so you minimize the number of settlements if you know that you have a 200 response ready for the customer before you take the payment.
Yeah, I mean, because an interesting problem there could be, right? You could have almost a race condition between verify and settle, where you can verify that the money exists in the wallet, but while you're settling, the money could have left the wallet already.
Well, I think
in which case, like you have done the work, but there's you can't really get paid for it.
As of right now, what that would take is a nonce invalidation. So if verify tells you that they have the money,
mm-hmm.
they would have to sneak in an invalidation of the nonce before you do your work and take the funds, right?
Yeah.
And so really, it's less than a block window, because verify just reads. And,
yeah, but
the window exists. If you let me finish but that's why you may want to settle beforehand, right? If it's a really high value transaction, you can settle before you do the work. Let's say I'm going to go do a bunch of GPU stuff. You probably want to get paid up front.
Yeah, because I mean for the deep research example, right? I assume you would want to settle beforehand.
Yeah, exactly.
Right?
So that failed the demo because funds, but
I see.
They accept payment and then they add it to a queue to process, and basically they have like the ability to cancel the work, right? Because they just cancel the queue item. if
Mhm.
payment doesn't go through. And so they throw item on queue and then take payment, and then if payment fails, they cancel task on queue.
I see.
But we have a bunch of middlewares and things that make it super easy. Like, by the way, if you're using Next or Express or soon Python, right now Go, like this is literally all you need to start accepting payments. It's literally that easy. One line of code was the goal. We got there. But, that middleware will follow that default verify, work, settle pattern in the middleware. But like if you go read the middleware, it's not complicated. It's like 80 lines of code. You can just manually call settle and verify and have whatever behavior you want. We have an example of this as well. So if you go into examples, TypeScript, where is it? Servers, advanced. There's a bunch of stuff in here on like how to do like more advanced conditions of paying. So, for example, if you want to defer payment, you want to like optimize for speed of response rather than guarantee of money. Like you can just do that where you return and then you do settlement afterwards.
Interesting. That makes sense.
Okay, forgive me for if I missed some of this earlier, but okay, so with these facilitators, you're effectively like an operator that's running the service, right? Running from what? So these would be effectively centralized entities running this sort of thing, right? So you're basically offering your version of x402 for the payments, and if you're offline, that payment can't happen. Is that correct?
That is, yeah.
Okay. Okay. Yeah. So again. I think when I start thinking about this from kind of like Lightning servers, for example, and we'll maybe talk about some Bitcoin and Lightning stuff as well in a second. But when we have servers that go down or offline, I can't make that payment to that. I can't I cannot fulfill that invoice in that sense, right?
Yeah.
So with this same concept, and if so, are there kind of how do we get around that, or can we leverage even something like these online networks that we have all the these distributed ledger technologies that we have all the time, just if that can fit in there as well.
Totally. So I'll show you how easy it is to switch facilitators. If you're a someone accepting payment, all you need to do is change out the URL in where is the line of code? This line of code. So facilitators under a standard, right? To change facilitator, you just need to point to a different URL. And so you could very easily just be like, oh, my one facilitator is down, I'm going to hop to another one, right? Most facilitators are going to have several nines of reliability. They're very simple services. There's an example in the repo of it's literally the facilitator we run on testnet. I think the problem with crypto people immediately jump to the make it a decentralized network of stuff, which love the vibe, but I think pragmatically, people just want something that works. And so could you have a decentralized network of facilitators that compete with centralized facilitators? You absolutely could.
Yeah, and I guess it's maybe more so how do we very easily make redundant systems, because again, and maybe this is something, just the unfortunate events that I've had with Lightning servers is, oh, we're going to use this server, the server's up and running, and all of a sudden it's not working or it's not configured correctly or whatever else. So just a little bit above my pay grade here on all these sorts of things, but just it's not so much about the decentralization, but the how do we have to have these redundancies to ensure that payments can happen, and if there's some sort of anyway,
you could again, it's literally
very
a URL to
configurable.
change, right? And so you could say every other request I handle goes to a different round robin every facilitator. Right?
Got it. Yep.
There's no gating to being a facilitator, and so you what has more uptime, all Web 2 services or any blockchain that isn't Ethereum, right? It's Ethereum has perfect uptime since launch, which is amazing, but I think it's a decentralized network of facilitators could exist theoretically, but I don't think it's the thing to spend time on right now.
Right now, yeah, sure.
Adoption and let's solve the problem when we get to it.
Yeah, all good. And then just from online, when Lightning?
When Lightning, I mean, we will accept any PR for any chains. If someone wants to Like I've talked to Jordy about
Perfect. He's
integrating
that's
Lightning to it, but he's been doing a bunch of like interesting x402 stuff with like proxy 402 and other, but
right. Yeah, like I know the L402 thing, and I think that was like more Lightning based. I think you touched on that earlier, or you said something with L stuff. So
yeah, Lightning 402, L402 was there's like a long history on it. So like LSAT was the original project, and then they renamed it L402, and then it was originally from Lightning Labs, and then I believe Jordy like was part of spinning it out of Lightning Labs.
Yeah,
That part
okay.
I'm a little less fuzzy on, but if you go read the older L402 docs, it says like previously LSAT, and like there it was all macaroon based and et cetera, et cetera.
I have a question to jump on what you say with Ethereum. So let's say I'm a user and I have USDC on ETH because I like paying. Like you are going to have something that allows the merchant to afterwards bridge on those different protocols, or like it works for all the chains? Because from what I understood, you did the presentation mostly on Base, because less fees, faster, stuff like that. If I don't have anything on Base or Solana or whatsoever, only on ETH, how does it work essentially? Because the fees would be much more expensive.
So we solve this by letting the server say I accept payment on these are the chains I accept payments on. I think like bridging is kind of like forcing a solution into something where it's like, actually, if you want to cast the widest net, accept on Base and Solana and Sui and Avalanche, and it's programmatic. You just add another chain, right? And there may be like different trade-offs of how much, like what your margins are on different chains depending on gas and et cetera, et cetera. But I think if you trying to build bridging into a solution like this is just the wrong layer of the stack. You could imagine a scheme in the future that says like bridge into like a currency on a chain. So for example, you may want to literally just accept any token on any network, but you want them to land in USDC on Solana, right? You actually can do that as a facilitator. You can encode that logic into a facilitator to perform that bridge action for you, but it's complicated and like there's other fish to fry.
All right. Any one more, maybe one more, and then we're gonna wrap up here. We're getting close to top of the hour, so.
Okay, I have two. I'll last one. About the validators. I'm sorry. I'll ask the other one. Actually, I could ask you this later. But so with the protocol itself, you said like when the web was designed, they left this 402.1 for later to be handling payments. And I don't know how many other there are apart from like the 200 or 404 or whatever. But you mentioned there's been previous attempts of like trying to fulfill that 402 by different parties. How does one proposal get accepted? Do they have a system that is like the EIP, or like how does that work? And how does like something like an image tag proposed by one individual get adopted to a code that I assumed was a library of predefined commands? How does this work?
So HTTP as a spec is governed by the W3 consortium, which is the foundation. And so if a new status code is being introduced, they're the folks who, do status codes. They attempted to do a payment system back in 2016. I went and checked today. Actually, there hasn't been like anything active on it, I believe, since 2019. Could be wrong on the year, but the problem is that they're trying to go via like traditional Rails, right? And so on the inverse side, like on the crypto side, so recap that. On the web side, W3 sets all the standards. I would love one day if x402 was like mature enough to be enshrined into a governing body, but it's not. So like we should figure it out, get a product market fit, and then once people are like universally using it, then it should be governed in like a more formal way. We got the image tag because Mark Andreessen said, "Fuck it, I'm gonna make the image tag." Like, and I think that who did Satoshi ask for permission to make Bitcoin? Right? Turns out you can just do things, and that's kind of the energy we're bringing with X402. Right? We don't claim. That's why the X is there. It's an extension of 402. Right? There's nothing official about it. We just think it's like a good idea for a spec and a protocol, and like if people like it, we'll enshrine it and make it more official over time. But right now, you just got to try stuff.
All right. Okay, one final round of applause. That's been an amazing. right. Well, thank you very much. And you gave out your socials and everything there. Maybe one final slide there if people want to get a hold. Oh, yeah, it's on there. We've got @programmer. And maybe just pull up your last slide there for people if they want to get in touch or learn more. cdpcoinbase.com and on X and Farcaster. So people can just ping you, reach out to you if they got questions, comments, concerns.
Yeah, hit me up. Make issues, make PRs. If you make anything with it, send it to me on X, and happy to retweet it. And yeah,
amazing. Okay, thanks again, everybody, for coming out. Appreciate you sticking through our technical difficulties. But and yeah, all those that have been listening afterwards, sorry about any audio dropouts. But we'll see you all next Thursday. If you can make it, that would be amazing. We're here every Thursday doing the same thing, whether it's whether we've got presentation or panel or something of that nature. Come on down. We're always welcome. And if you don't mind, just fold up your chairs afterwards, and we'll just kind of tuck them behind, and off we go. Stick around for a little bit, and